record it. That's part of this protocol. I realized that it probably be good to have you guys join a remind. That I'll set that up for tomorrow. So one of your assignments tomorrow will just be joining our remind class, and I can send text that to you guys easily. I know you check that a little bit more than email. Okay, so if you recall, what we did yesterday is we talked about search, because search is such a key idea in computer programming. You know, there's tons of data and we need to search through it, right? Whether it is you know, something that we're just creating, you know, just to hold the data, or maybe we're searching through a large database or something. So search is key. If things are not in any order, well, all we can do is a linear search. Oh, I thought we did this yesterday. Oh yeah, we did in array searching. So we talked about if things are not in order, we have to do just a stupid linear search like we did yesterday here, where it really just has to go through one value at a time. If the value is what we want, well, we return it in some fashion. Otherwise, at the end, after we've searched through everything, then we know it's not there. But this, you know, if we have 1 million or 1 billion entries, it's going to take us 1 billion things to look through. Clearly not very efficient. So we talked about how if things are in order, we can do what's known as a binary search, right? And a binary search, you know, starts in the middle, and every time it eliminates half of the values. So it's much more efficient. It does require the data is sorted, which takes some time. So if you're only searching for like 1 or 2 things, it probably doesn't make sense to sort it. But if you're repeatedly going to search, a binary search is it can be way more efficient. Okay, so I thought it would be fun to do a little bit more practice with this. Okay, so what I have for us today is a list of passwords. So and it is like 10 years ago, or probably more at this point, some major website was hacked. I don't remember what it was. And you know, they had 30 or 40 million users, and every person's password was revealed. And whoever did the hacking actually put these passwords online in a file. And it's kind of fascinating. You get kind of into the hidden psyche of people. These are, and I just for time's sake, I didn't, oh, what happened? Where'd it go? I didn't put all 30 or 40 million, you know, just because our computers really can't handle it. So it's like I have a list of 2 million passwords here. I believe it's 2 million. We can look it up. And these were people's real passwords. You know, we can scroll through, and you know, just right off the bat, we should, you know, some of these things, or a lot of these have curse words, are racist, are awful, but you're kind of getting into the hidden psyche of people when they think that they're never going to be revealed. Just a little side note: passwords and in any real system are never, like the people who coded this did it really, really badly, in that whenever you make a password, it's hashed, in that it's never saved in the text form. That's why when you like go to reset a password, they don't send you back. Like they can never like remind you what your password is, because they don't know it, and that's a key thing to security. But this website was really poorly done, and that's so anyway. So we have all these passwords. Okay. You can see lots and lots of them. All right. Does that make sense? Is everybody with me? I wish I could see who do we have here. Okay. Oh, we got everybody. Wonderful. So this is the list of passwords. Okay. It is sorted. I already have it sorted. All right. So, oh boy, here. All right. In this file, I'm keeping it in an array list this time. Okay. If you recall yesterday when we did, I had an array, and I thought it'd be good to do it in an array list, and it's an array list of strings, because passwords, obviously, you know, here it is. Obviously these are strings. All right. So it reads them all in, reads the next password, adds it. So you can see it reads it in from the file. I'm kind of curious how many passwords there are. Just I forgot how many I put in here. All right. No, it's only 200,000. So I only just for efficiency on the computer, I only, so it'd be a little quicker than what we were doing yesterday. I reduced it to 200,000. Again, the website had 32 million. What I did is I got that file and I randomly took 200,000 of them. Okay. And again, some of them are offensive and a lot of them have curses in them. So just deal with that. All right. So the first is a linear search. And I want to find the location of the first time the password was used. All right. So this is a stupid linear search. All right. Does anyone want to write this for me? And again, my array list is called all passwords, and it's an array list of strings. And what I like someone to do it with a traditional for loop. Can someone do that for me?
For int I equals 0, I is less than all passwords dot size, and then I plus plus.
Excellent. If
all passwords dot get I is equal to password or dot equals.
Dot equals. Oops. Okay, password that we're looking for. Probably one too many of these. All right, what do I do?
You would return get I. All passwords dot get I.
That would be the password. I want the location of the first time it occurs. So that would be return.
The index of?
Yeah, which is what?
All passwords.
No. It's just I. I is the index.
Oh, okay.
Yeah. And then if we don't get to it, generally I probably should have put this in the header, but return -1 if it's not found. Okay. So I think in my system void main, I call it looking for peace. Let's find out when peace was called. Testing linear -1. Uh-oh. Peace is not here. Anyone see where we made a mistake? That seems hard to believe. So I'm gonna scroll down and see if peace is here. Peace. Oh, lots of peace. So it really should have returned this number, 154,000. So peace, linear search. Does anyone see an issue? If passwords, all passwords dot get I dot equals password. It's not what I was expecting to happen. Exception in thread main. All right, yeah, I'm gonna uncomment this out, but that's not the problem. So testing linear, p dot linear search piece. Wow. Huh. I am confused. -1. Someone help me out. I'm struggling here. So I call it down here. P is new passwords. Testing linear, p dot linear search piece. Piece was in there. Let's, for giggle's sake, I don't see anything wrong. I'm going to print out all of I'm going to print out every word just to see if it's matching what it should. So I don't see anything we did wrong. So I'm just going to do a system.out.println that prints out all passwords.getI. And let's see if we can see where I made a mistake. Oh, it sure looks like it read it just fine. But oh, look at that. It only seemed to have, these are weird, isn't it? It only read up until this one. All right, let's see here. So I'm not.
Is there an issue with like Eclipse itself that it can't search more than?
I don't think so. I wonder how I read it in. I wonder if there's a problem in this file. So the last thing it read was 5 this. Sorry guys, sorry for the issue. I thought I'd be all set. 5 tactical and 5 this is. So it had trouble right about here. I don't see why. Oh boy. Oh boy, guys. So out. So I'm seeing if there's an error. I'm printing out the error. Let's just see if it has trouble now. 1 bubble. So it's not reading everything. It's only reading the first bunch. This reads in the next password. Sorry, guys. Sorry. I'll print it out up here while we're reading it in and see. And every single time I'll print out how big all passwords is. So you can kind of, maybe this is worthwhile. We're seeing ways to detect what's going on here. All right, so it read it up to 18,672. Then I thought it was done. It says scan.has next is not true. Why would that be? Why would that be? Yeah. So it's only reading in this many entries. Is there a reason for that? So maybe you write about Eclipse. Maybe I have some limit on how big my array list can be. All right, at some point we're just gonna have to scrap it and keep going forward anyway. So Java array list max size. All right. So theoretically, it can hold 2 billion. All right, for giggle's sake, let me get rid of a couple and see if there's something wrong with how one of those may have been written. Let's try it again. Yeah, I wonder if there's something wrong in the file right there, because it worked a lot. It worked. Wow, I didn't think that was going to work. So I got a feeling maybe there was when I imported this file, maybe I messed up on one character. So all right, now when I run this, it works. Linear search finds it here, and I'm sure that's where it occurs. Okay, so that's just a linear search. Not much to it. Okay. Now I want to take what we did yesterday and do a binary search. Right? This one again is way trickier to write, right? But it's gonna be exactly what we did yesterday. So if you recall yesterday, we had a low index, which is gonna be 0. We have a high. What's high going to be? Where do we start off high in the beginning? So we're kind of like putting boundaries around it. What should high start off with in this case?
All passwords dot size -1.
Oh, -1. Good point. Excellent. I forgot about that. And then middle, of course, is where you're just finding the average of those two. And then if you recall, the next thing was we had a while loop. So we keep repeating this while low is less than high. So we want to keep doing this. We want to keep adjusting. And then we said if, all right, let's see. So if all passwords dot get I, so if the password you get, and then how do we check to see if it comes before? So if it comes before the word we're looking at, how do we check that with strings? Does anyone remember? So how do we compare two strings to see which one comes first alphabetically? Anybody?
Index of.
Index of will tell us where in a string another string occurs. So like if we want to
Compared to.
compare to, yep. Oops. So yeah, so it's a different way for us to compare. So compared to what? Well, compared to password. If that returns less negative, that means we came before password. So the phrase we're looking at in all passwords, if it's a negative, that means we came before. So that means
So middle equals high.
middle equals high. No, we don't change middle yet. We're going to change high and low first, or high or low. Which one gets changed here in this case?
High.
So I think it's low. Let's think that through. So if the word at our location, so let's say there's 1,000 entries. The one we're looking at 500. If it is less than password, meaning it comes before password, then low equals high plus 1. Is that right? No. Oh man. Low equals middle plus 1. We've checked middle out. Oh man, it shouldn't be I, it's middle. All right. So low equals the middle plus 1. We don't adjust the high. So now we're saying, okay, it must be between 501 and 1,000 or 999. So we move the low up to one more than the middle. And then
I have a question.
yeah.
So compared to password, less than 0
Yep.
would mean that our middle, or the word that is in the middle, is more.
Less than means our word in the middle is it comes before.
Okay.
Yeah. So if it's less than, it means we came before. So like if for example, if password is peace, okay, and if password is peace, maybe if middle word is Nancy, and if password is peace, it returns less than 0 because Nancy comes before peace. I'll look later. All right. Now, so low is that, and then middle gets adjusted. Middle is always the same formula. Okay. It's just going to be the new low plus whatever high was. So 501 to 999, we find the middle of that. So that's like 750. So that's our new middle. And we're going to have pretty much the same thing that we did yesterday. Else if, oh boy. Else if it's greater than 0, well, that means the word in the middle is after our password. So we need to adjust our high. Our high is going to equal what? Someone else fill this out for me. It's not going to equal this. What would it equal? You guys with me? I know this binary search is really challenging. So if the word in the middle, Nancy, compared to our password, if it's positive, that means Nancy comes after the password. So what are we going to adjust? Our high now is not going to be 1,000 anymore. What's the highest number that it could possibly be? If the middle is 500, what's the highest? What's the highest it could possibly be? Anybody there?
500.
500. And really, we already checked 500. So I'm going to do 500 minus 1. Okay. Now, in the last case scenario, what does the last case scenario mean?
It is.
It is it. Exactly, Gianni. So, so it is it. So, you know, we can almost say return middle. There's only one problem with this. If in our list, we're looking for peace. All right, peace. And let's say we're here. I really want to return this entry. right? Because so middle just by chance might find this one. So we just need to go back in time, and that's really just gonna be a linear search. We're just gonna go back up until we find one that's the one we want. So it's almost return middle, but we want, while the number before, so while all passwords dot get middle, so while the one before, and middle was it, so while the one before is still equals password, then middle minus minus. So while the password before us still is password, let's just keep going back. It's just a little issue here, okay? And this is it. I have an error, compilation error, because it's saying you're not returning anything. How do I fix that? Well, after everything, I'll say return -1. All right, because if I got here, that means you know, I didn't find it. So this is a binary search. It is tricky, but we keep track of the low and the high. It'd be easy if, you know, a little better if we had a chalkboard, we could do this. And then the middle point every single time. If we keep repeating this whole process, every time we get rid of half the list, and unless we found it, in case we go backwards until we get the middle. So we'll run that, see how that worked for us. All right, binary was looking for whatever. It found it at 195,371. Okay, so that's a binary search, and we can do some kind of fun stuff with this. So, all right, using binary search, find how many times password has been used. So first, so they're going to put some password in. Maybe the password is dude. I want it to return how many times dude has been used. Okay, so what I'm going to do is I'm going to find the first time that it occurs. So, oops. Int first location equals, well, I'm going to call my binary search. Binary search of your password. So I make a call, and that's the first place it occurs. Now, there's a possibility that it's not there. So maybe I'll say if first location equals -1, well, then I return 0 because it doesn't occur. Else, all right, else, so if it gave me -1, I did not, that wasn't there at all. Else, I want to count how many times. Is this going to be a for loop or a while loop? I'm going to have to repeat. Is it going to be for a while?
A while loop?
Yeah, how come?
We don't know how many times we're
Exactly. So it's exactly the same logic I did here, all right? And I might even copy it in just for time's sake. So while all passwords dot get first location +1. So while the next one is still password, right? Then well, I probably need a variable that's keeping track. Int count equals 1. Originally it's 1. And while the next one equals password, well, my count is going to go up because I found another one. And then I'll say first low ++. This is a little goofy. But so I keep saying, all right, I keep moving my index along. And then after my while loop is done, what am I going to return?
Count.
Yeah. So the idea here again, if the location is -1, well, I return 0. I didn't find it. Else, I know I have at least 1, so I set it at 1. And then I say, while the next one is still my oh, it shouldn't be password here, your password. So while the next one equals your password, Well, I found another one, count plus plus, and then I changed first lock. Again, first location isn't, maybe I named it poorly, but the next one is also that. And then I look to see if the next one's there. So now if I run this, let's see how many times dude has been used. Dude has been used 9 times. All right, fantastic. What's a common password? Let's change that to a common password. What do you think people would use as a password a lot in the real world?
1, 2, 3, 4.
Let's see how many times 1, 2, 3, 4 has been used. 82 times. Oh, I shouldn't say dude. Right. So 1, 2, 3, 4 has been used 82 times as a password. And you think that's 82 times out of 200,000, which is, I don't know, point something percent. So it's not a ton, but if you were writing a hacking program or a program to guess passwords, well, that would not be a bad one to use, right? Because that's there. Let's do a for each loop. So find all derivatives of word. I want to find all passwords. This is a perfect one for what you just said before, Xander. So find all passwords that have the string word in it. All right. So if the word is dude, all right, then if they find dudette or I love dudes or dudes are cool, all of those would have it. I think we can't do a binary search because it could occur anywhere, and our list is just sorted. So someone write a for each loop, because we did a traditional one. Let's do a for each loop with array list.
For each password X in all passwords.
For each password X in all passwords. Yep. If
ouch.
Someone else want to jump in and help? Or if you see an issue so far?
Do we need to use something other than passwords, like so that we can find words?
Right here, you mean? Or
Yeah.
Yeah. What is all passwords made up of? It's not made of passwords. We don't put the word passwords here. What's it made up of? What kind of variable type?
Strings.
Strings, yes. So for every string, he's calling X in all passwords. I want to know if X has word in it. What method do we do on that? So if I say X dot, well, I see a whole lot of them. There's a lot of methods. Oh boy. Which method is going to allow me to find out if word is in it?
Index of or equals.
Index of. Equals would only be exactly. And index of will tell us, even like if the word is dude index of is 0, so it works. So index of word. And how do we know it's in the word? Index of returns
greater than 0.
Greater than or equal to 0. So if it's like if the word was dude, so if password was dude and we wanted to know if it contained dude, or we wanted to know if that would return 0 because it occurs at the 0 character. So if x.index of word is greater than or equal to 0, well, I guess I need a counter again. So count equals 0. If this case, I say count plus plus, and then after everything, I'm going to return count. Uh-oh. Find all passwords. Oh, I guess we're just supposed to print it out. I'm sorry. So system.out.println. Okay. So this would print them all out. Find all derivatives of dude. Let's see every password that has dude in it that people came up with. Yo, dude. Whoa, dude 8. Why, dude? You are one gay dude. Sweet dude 1. Skier dude 3. Rock on, dude. on, dude. Fun time, dudette star. Oh, some nasty ones. You get the idea. Okay. And just in the last few minutes, I want to finish by about 10:45. I got another Zoom at 11. Let's see if we can do this. I want to find the top passwords because this might be useful if we wanted to create a
Hacking bot.
yeah, exactly, a hacking bot that would throw them in. So let's find all passwords that have been used more than 100 times in the list. I think might be useful. Okay.
It'd have to be a linear search, right?
It would have to be a linear search, but we could do find how many. So I like to do a linear search. So for every string in passwords, right? Well, I'm going to call my method because I have this method. There's probably more efficient ways to write this, but not easier ways. Okay, int num times equal find how many x. How many times is x? All right. Now, all right, what are we going to say? If num times, they want to return an array list too. If num times is greater than or equal to how many, some limit. So I need to add it to my array list. Shoot, how do I do that? So what am I going to need to do first? All right, this is always your strong suit.
Just like make a new array list.
Yeah, and the general format array list string. I'll call it my top list. New array list parentheses. So this is the structure of an array list, and then if that password has been used more than how many, I want to add it into my array list. How do I do that, Arias?
You just do top list dot add, and then
Yeah, what am I adding to it?
num times.
That would be how many times it's been used. I want to add the word. What's the word known as?
Is it x?
It is x. And after everything, I return top list. Okay. So I return top list, and then listing all passwords here. I'm for every password in the top that have been used more than 100 times, I'm going to print it out. Let's look at this. There's an issue, I think. We'll see. Oh boy. Array index out of bounds exception. Let's see where that occurs. Password. This line caused an exception. Oh. So we're trying to access -1. So while middle is greater than 0 and, because I don't want to go back in time, for the 0, 1. Does that make sense? So I was crashing because I put 0 in here. 0 minus 1 is -1, and then I try to go back. That's a problem. So I think we just make sure. Okay, stalker has been used 140 times. Oh, this is annoying because it lists princess 1, princess, password, listing them many times. So why is that happening? Can anyone explain that real quick? Why is it listing password 1 289 times, many times?
Oh, because there's no.
Because for every password, password 1 is many times. Every single time it sees how many times, 289 times, and it adds it. So we only want to add it if it wasn't already there, okay? So there's a couple ways around it. The easiest way, and this is something we haven't talked about yet, is I only want to add it if it's not there, okay? And array lists are cool. There's another method in here. If top list dot, do you see one in this list that might be useful? Who sees a method that's popped up on the screen that might be useful?
Contains.
Contains. If it contains X, well, if it doesn't contain X, so if it doesn't contain X, so if not contains, then add it. All right, there's a lot of stuff. Did I hit? I hope I hit to make a copy, to make a recording of this. All right, because I know we've gone over a lot of stuff fast. Oh, this is nice. So here are all passwords that have been used at least 100 times. Fascinating stuff here, folks. So password has been used 433 times. That's roughly, 0.3% of the time. Like with just, I don't know, what is that, there's about 14, 13 passwords there. With 13 passwords, that's probably like 2% of the time they've used one of those passwords. So you have a 2% chance if you had to guess someone's password of using that. Wow, Nicole, 103 times. MySpace
Password.
Yeah, so kind of cool. I love you. Isn't that sweet? Oh, that's great. All right, so that's what I wanted to go over today. Your homework. Let me just go over things. Tomorrow is going to be a free response problem. We are not meeting tomorrow. I have another Zoom, and I want to give you the day off. Thursday, we'll do another Zoom, okay? So at least this week, it'll be Monday, Tuesday, which we've done, and then Thursday. Friday will be your own work. Wednesday will be your own work. Does that sound good?
I have a question.
Sure.
I had another class who had a Zoom exactly at 10.
Yeah.
And I had to miss that one for this one.
Okay.
So how's
Yeah, good
what am I
question.
supposed
So yeah, a couple things about that. We won't do this every day, so hopefully, that you can make some of those sometimes and make some of mine sometimes. If you must miss it, like if it seems like it's gonna be an important one, or you feel like you need to go to that one, I will record these. I hope I recorded them. I'm not sure if that's the record symbol or just the sharing symbol. So I hope I recorded it, but normally I will try to record it and then I put them on YouTube. If you go yesterday, you can click on this video and you'll see the entire chat from yesterday. And I would do that. With every time we have a conference. So it's totally fine if you miss it. If you do miss it, I want you to watch that video and just send me a quick email or if that's the case. Just saying that you watched the video, so I can just mark you that you've attended class. That's how I take attendance. All 5 of you are all set. I've taken attendance. You're all good for the day. So actually I'm going to change that. This will be on here. It's just some questions from the book. I'm going to also add a quiz just to practice some of this searching stuff. I'll add that in a few minutes. And that's it. That's your only assignment. Tomorrow will just be a free response that I want you to do. And any other missing work you want to do. So it shouldn't overload you at all. And then Thursday we'll come back, and I think we'll probably talk about sorting on Thursday.
What are we doing today?
So today there'll be this homework, which is just some questions from the book, and there's gonna be a quiz on searching that I'll add in a few minutes. So that's it. If you missed, so some of you guys missed these free responses from last week, I would like you to do those. Okay. But not too much. Any thoughts? Any questions? Anything you want to talk about before I turn this thing off?
Nope.
All right. Well, have a good. Looks like a sunny day out there. See if the snow is going to melt real quick. It might be your last chance to make a snowball and throw it around. Besides that, have a good Tuesday, and I will check in with, I'll check in tomorrow, just on, put assignment up and stuff, but we'll meet again on Thursday. All right. Glad you guys all make it. I'll talk to you guys later.